The blockchain is an undeniably ingenious invention, the brainchild of a person or group of people known by the pseudonym Satoshi Nakamoto. But since then, it has evolved into something greater, and the main question every single person is asking is, what is blockchain? In this video, I'm going to explain you what the blockchain technology is and what its properties are and what makes it so unique. Blockchain, as the name implies, is actually a chain of blocks, but not in the conventional sense. A block contains digital information stored in a chain, which is a public database. Despite all our apprehensions and all the hacks and scams involving Bitcoin that occurred last year, blockchain is the technology for all future financial transactions all over the globe and much more. Blockchain is the record-keeping technology behind Bitcoin and is actually a distributed, decentralized public ledger which stores information about transactions and their participators, besides information that distinguishes one block from the other. But let us first deal with the decentralized processing of transactions. In a centralized entity, all data are stored in one location only, which can be accessed only by directly interacting with the entity like a bank. If you want any information on your account, the only way to have it is interacting with the bank. The traditional client-server architecture is built around this centralized entity concept, in which a query is sent to the server, which then responds with the requested information. But this architecture also poses significant risks. Since all data are stored in the server, it becomes the sure target of hackers. Upgradation of the server software also poses problems for users since they cannot use it while it is being upgraded. If a malicious virus is able to gain access to the server, it may corrupt the entire database. This is where the decentralized systems are superior. In these systems, data are not stored in any centralized location but distributed throughout the network, making each user the owner of the information. It is then not necessary to interact with any particular computer in the network for accessing information which can be obtained from any computer in the network. In this scenario, that is, in the bank scenario, it is not necessary to interact with the bank to send your money to someone. You can directly send it without having to go through the bank. Being decentralized, the blockchain architecture has no centralized points of vulnerability that hackers can exploit. Besides, instead of the usual username password system of online security in a centralized system, blockchain uses the much more robust security of encryption. This was the concept underlying the cryptocurrencies, which have no physical form and exist only in the network, which is completely decentralized. The currency cannot be regulated by any central bank, neither can it be, unlike paper currencies, redeemed or exchanged by another commodity like gold, since it does not have any intrinsic value. Whenever a new transaction occurs, it creates a new block with a new data which is added to the chain, provided the transaction is verified not by any human being but by the network of computer itself, a network in which more than 5 million computers are now connected worldwide. The block thus created is given a unique identifying code called a hash, by which it is distinguished from all other blocks and is added to the existing blockchain, where it now becomes visible to all computers connected to the network for viewing, making it completely transparent. Of course, personal information about the users remains hidden, and the only user information that is visible is their digital signatures or usernames. This hash, which is actually an algorithm, lies at the heart of the blockchain technology, just as blockchain is at the heart of cryptocurrencies. Hashing converts an input string of any length to an output of a fixed length. For a cryptocurrencies, transactions are taken as input, which the hashing algorithm then converts into an output of a fixed length. In a blockchain, new blocks are continuously added to the end of the chain, that is linearly and chronologically, its position being labeled as height. Once a block is added to the chain, it is virtually impossible to alter its contents, as the function that creates the hash code which identifies a block actually converts its digital information into a string of alphanumeric codes, which is basically the combination of numbers and letters. And any editing would also change the block's hash. The next block in the chain will still contain the old hash, and a hacker wanting to erase that must update every single block after it on the blockchain, which is virtually impossible, and that is what makes the blockchain so secure. Another way the blockchain is secured is by requiring any new entrant, that is a computer, into the blockchain network to prove itself by passing some test, of which there are many. Bitcoin, for example, employs a technique called proof of work, in which computer aspiring to join the blockchain must solve a complex computational math problem, the odds against the solving of which is about 1 in 7 trillion. To overcome the odds, the computer must run programs costing them significant amounts of computational power and electricity, and hence money. The cost would be so prohibitive that for a hacker wanting to steal financial information, it might not even be worth the trouble. Thus, blockchain serves the objective of creating information that is truthfully recorded and distributed but cannot be edited or even copied. The blockchain is not only shared and maintained by a public network of users, it is also consensual. The blockchain protocol discourages multiple blockchains through a process called consensus. If there are multiple and different copies of the blockchain, the consensus protocol will adopt the longest chain available. Thus, the longest blockchain will also be the one earning the trust of most users. By allowing digital information to be distributed but not altered, blockchain technology has created the backbone of a new internet. For economic transactions, it enables an incorruptible digital ledger, allowing cryptocurrencies like Bitcoin to flourish. Blockchain ensures accuracy of data, minimizes cost, and improves efficiency, privacy, and security. Banks and financial institutions will of course be the largest users of blockchain, but there will be many other sectors and industries that will derive benefits from the technology. Example, healthcare to securely store their patients' medical records, or in real estate to secure property records, or in supply chains to record the origins of materials. Blockchain can be used in smart contracts, computer codes to facilitate, verify, or negotiate a contract that will execute when specified conditions are met. Most importantly, it can be used in elections because voting with blockchain can eliminate election frauds by making each vote stored as a block on the blockchain, rendering it impossible to tamper with. The blockchain protocol would also maintain transparency in the electoral process, reducing the number of personnel needed to conduct an election and provide officials with instant results. It was tested in the November 2018 midterm elections in West Virginia with encouraging results. It can be used in advertising industry to track advertisements on the internet, in the music industry to track songs, in banks and mortgage companies to track deeds and documentation, in the shipping industry to track bills of lading, in the pharmaceutical industry to verify the drug supply chain, and in many other ways not yet conceived. Undeniably, blockchain will be the technology in the future. So that's all for this video. If you like the video, hit a thumbs up, subscribe to the channel and share with your friends. Thanks for watching. Let's meet in the next video. Thank you.